Essential element of language is you need to know who did what to whom. How do you tell people who did what to whom? Well, you are familiar because you are in America where you speak English in which the word order is fixed and it works like this. Consider the sentence, the child saw the elephant. If you juggle around with the word order, the intuition of the native speakers wouldn't accept that. But wait. Consider a language such as Malayalam which is spoken in India. Even if you change the word order, the native speakers do accept them and as such the meaning doesn't change. The same goes with many free word order languages spoken across the world such as Russian, German, among others. In short, there are both fixed word order languages as well as free word order languages. Both tell about who did what to whom, but in different ways. Does the human brain analyze these two types of languages differently? How do we even go about answering these questions? We cannot just cut open the human brain and see how it's processing language in real time. Perhaps language could show us the path to answer this exciting question. Linguists have come up with 3 different ways of understanding the relationships between words in a sentence. 1. Grouping. What do I mean by grouping? On the one hand, we have the word saw, and on the other hand, we have the elephant. So I'm grouping saw and the elephant as one, but I'm not making any claims about what it means for them to go together. This grouping depends only on the order in which you hear them. 2. Dependency. This means I am not just grouping them, but I am also saying something specific about the relationship between the words. I want to group these words, but I also want to say that there is a strong relationship between them. There is another possibility. Adjacency. Here, it means that there are words in a row and they are connected with each other either to the right or left. So the structured or unstructured grouping depends on deeper grammatical properties. Are they really 3 distinct things? What if they are not? What we have shown in this work is that you can mathematically boil down the 3 ways to the same thing. Well, I'm not going into the detail now, but what is the outcome? That these 3 theoretical possibilities can be unified. So the math tells us that they can actually be unified. But how do you test that? And how do we know that that's how humans do it? Luckily, there's an interesting data from fMRI studies that shows that our brain processes these possibilities in a similar way. And they have identified regions in the brain which processes these structures and indicated an interaction between those regions. I'm not going into the details of how humans process it because that's another whole talk on it. This is how mathematics can tell us something about how humans work. This is one way in which math can help us understand the brain better. In conclusion, math matters.